Well, working out here in the cold today with my brand new camera, so you guys have to let me know how these shots turn out. This is an old school vehicle, a 1993 Oldsmobile Cutlass Sierra with a 3300 engine. Symptoms with this vehicle, at least what I'm told, is it will not start unless the mass airflow is unplugged, and I'm not sure how it runs other than that. So let me get you a shot of the engine and I'll crank it over and let you listen to it, and then we'll figure out where we're going from there. As you see, the air filter is removed and the mass airflow is unplugged. I did not do that. This is the way it was when I opened the hood. The only thing I did so far off camera is try to crank it. So let you listen to it. As you can hear, it is a no start. Now I'm by myself, so having someone crank it for me and getting some direction here might be a little bit difficult. One of the things we can try on this type of system, these GM Type 2 coils, just to see what we're missing, is we can actually pull the plug wires off of one of the coil packs, and I should be able to see that inside. And what we want to watch is it jump the gap right there. Again, this is for these Type 2 coils that GM uses. Pretty sure the camera picked that up. I saw the spark for sure. I'll show you guys one more time. Okay, and it is a consistent spark. All right. Okay, so we have spark. What is the next step? Well, we're always looking for the next easiest step. We have fuel pressure and injection pulse will be the next two directions that we'll take. My hands are a little bit tied on this system. This is a OBD1 or pre-OBD2, whatever you want to call it, system. And I do not have the adapters with my new Veris Edge to communicate with this. I have an older scan tool at home that I could have brought. I just didn't expect to be working on a pre-96 car. So scan data is not going to help. We could jump the data link connector and count the flashes of the light. That might be something that I should do just to teach you guys that don't know how to do that. So maybe at some point in this video, I will show you how to get flash codes out of this. As far as helping us though troubleshoot this no start condition, I don't think that's a very fruitful path to take, because these older systems, they didn't set a lot of fault codes for no start problems, and when you have spark like we do, that tells you your cam and crank signals are probably okay, and there's not going to be trouble codes for this, but we'll do it later. So let's focus on the system and let's pick a direction that is fast. Some of this may have to do with experience. We'll get you back on the engine. So this is a system, this 3.3 liter engine, or 3300, whatever you want to call it. It says 3300 on top of the intake. This is one of those systems that use Multec 1 fuel injectors, and you guys that have been following me for some time would understand that the Multec 1 injectors that GM uses are known for shorts. For me, as far as speed goes, the next thing that I want to check on this system is for shorted fuel injectors. And the best way to do that, let me just see the plug design on this. That's ignition. All right, so my injector wires, this is the main harness right here, and the injector wires actually run up to here. There's a dark blue. If you look at this front bank, there's a dark blue and a pink, and then there's a green and pink in the back that you guys aren't going to be able to see behind the intake here. I'm going to grab those up here in this location and really just look at the current ramp patterns on the scope to tell me whether or not we have a shorted injector. I'll show you guys a more simple way to do this if you don't have a scope, but I'm doing the scope one first because I may have a limited opportunity to show you this. The car may end up starting. That's what happens with these. It'll be intermittent and random. And, you know, with the customer saying that car starts with the mass airflow unplugged is evidence of that intermittent nature. I don't believe that this has anything to do with the mass airflow at all. In this main harness, I only see one dark green, solid dark green wire. There's a green and white, light greens in there. So this is definitely one of my injectors, one of my bank of injectors. This would be this back bank right here. And then I have, there's two dark blue wires. One's a little bit thicker than the other. I'm gonna guess it's the thicker one, just based on the size of the green wire here. So I'm gonna guess it's this one. If it's not, we'll just switch it. So these two wires right here will allow me to look at all of these fuel injectors, and I can do them one at a time or I can do them together. So let's get the scope set up. Just going to use an inductive amp probe connected to my Picoscope, and I'm actually going to do these at the same time first. These are polarity sensitive. I have the arrow pointing away from the injectors, which should give me the correct waveform. No big deal if I'm wrong, we just flip it over. Get you guys a quick shot of my mobile diagnostic unit. There's my Pico laying on the ground, and my laptop's inside my truck. And you can kind of just see the top of it right there through the window. So not exactly the greatest place to film and work, but hey, it is what it is. I'll throw the Pico screen over on the right. Let me turn channel 2 off. Let me turn this trigger off. Channel 1, we're going to set this to my amp probe, which is my 60 amp current clamp in the 20 amp mode, and we'll set this to a full 20 amp screen because I expect we are going to see some shorted fuel injectors. Man, I messed with my settings here for sure. I need to redo this. I set my sample rate to 2 mega samples because I'm going to gather a lot of data. I'll set this to a 500 millisecond screen. Nope, we'll set it to a 1 second screen. That'll give me enough time to crank it over. Looks like maybe I was wrong here, guys. That looked like a pretty good waveform. And it actually sounded like the car almost started too. Okay, so these fuel injectors, so we're clear on this, these injectors will draw about 0.7 of an amp a piece. There are 6 of them. So we should have roughly 4.2 amps of current if I am grabbing all 6 of these together. Yeah, this actually looks really good, guys. This is not shorted injectors. I was wrong in my direction. The top of this spike is 4.3 amps. That is for sure all 6 injectors. You heard the car almost start, so my suspicions of shorted injectors are wrong, but hey, no big deal. That was a really fast test. It took me longer to set the scope up and get everything turned on filming wise than it would have if you were working by yourself. Literally, that is a 2-minute test to check for shorted injectors. Again, I will put links to my other videos that have shorted injectors within the description of this video. and that will help for you guys that aren't really quite sure what I'm talking about as far as these Multec 1 injectors go. The next step for this is going to be fuel pressure. I should have checked that before. I did not. No big deal, we move on. That's the way this goes. Pick a path, come to a conclusion, back up, go another direction. That's exactly what we're going to do. Last comment for you guys that were concerned maybe that line looked like it was straight up right here. It's not. This is just a really long pulse width because we're cranking. So this is a normal looking waveform. Well, I forgot my fuel pressure kit today, so I'm borrowing Pete's. And as I'm thinking about this fuel system, one of the questions I have in my mind is, do we have a prime? And if we have a prime, I'll go one direction. If we don't, I'll go another direction. So let's look at that gauge. And I'm just going to turn the key on, and let's see if we get pressure when I turn the key on. Oh, I had the key on already. So on these GMs, when you turn the key off and turn it back on, you have to wait about 5 seconds between cycles for the computer to run the pump again. Make sure you guys can see that gauge. That moved a little bit. Having a hard time setting this up. You guys are going to look at it upside down. All right, turn the key on. I did not hear the pump. As you can see, we do not have pressure. I don't know if that gauge moved at all. I'm going to do it again. I shut the key off, wait 5 seconds, turn the key back on. I hear the relay click up here, but I did not hear the pump in the back. So let's crank it over now and see what happens. The car almost started last time. And what I'm thinking about, guys, is we may be running through the oil pressure switch to run this pump right now, and we have a relay issue. So let's watch the gauge, and I'll crank it. Nice. All right, so my initial direction with shorted injectors was not the right call. No big deal. I think if I would have not known this system, the next step would have been to check fuel pressure. And we are there right now. As you can see, this is why this vehicle is not starting. We are not building fuel pressure. My suspicions are if I crank this long enough, we'll get this pump to run, and that would be going through the oil pressure switch. I will put a link in the description of this video that deals with fuel pump electrical circuit designs and GM's oil pressure switch and what they're doing. In short, for now, the oil pressure switch that GM uses will bypass the fuel pump relay and allow the pump to run in case of a relay failure. As I'm trying to put this together in my mind as to why the car may start with the mass airflow unplugged, yeah, I can't really put that together yet, but it would go into a richer strategy, and that may help a vehicle that is having issues with fuel pressure as far as getting more fuel to the engine, allowing it to start. I'm not sure about that yet, but I guess what I'm thinking about right now is what direction do I want to take you? Do we want to go right to the relay, or do I want to crank it and show you that if I crank this long enough, we will build oil pressure, and that will close the fuel pump switch and make the pump run? I think I want to show you that. Something else we can do too is we can do a quick measurement of current for the fuel pump right up here under the hood, but I'm just going to keep cranking it and in hopes that I can build enough oil pressure. It's really cold out here too, and this is the symptoms with these. They'll crank a really long time. Filming this and doing this in off camera can sometimes be two different things. If I'm off camera, I am not going to crank the crap out of this engine and potentially kill my battery and make this harder to troubleshoot. But from a standpoint of showing something like this on film, I really want to catch it, because I think that's the problem. It's not, the car is not a no start. It runs, it just has a hard time starting. That's what I was told. I'm gonna keep cranking it. Still nothing. Okay, I need to change direction again, guys. I have to, because I can't afford for this battery to die out here. I need to do my checks at the fuel pump relay now. This relay is one of these three right here, and I'm over on the passenger front of the car. What I'm looking for is one of these relays will have a heavy gray wire going to it, and then a green and white control wire. How would I know that? Because GM has used the same design forever for their fuel pump circuits. And maybe I'm wrong here on the location of this relay. Oh, I missed one right here. This is it. It's the one on the end. That's right. GM has used a separate fuse for this. It's covered underneath that. I'll get you a better angle of this. So this is my relay right here. And there's a fuse that runs up here. It's got some green cruddies on the wire right there, which are not good. Might be a suggestion of where we're going. And so that's the fuel pump fuse, and then my fuel pump relay is right here. And then the nice thing about these GMs is they give you a jumper for running the fuel pump. That's this guy right here. So if I run direct battery voltage to this, that will bypass the relay and force the pump to run, and that'll give us some real good direction. So that's the test I'm going to do first. Let's jump this pump and make it run and see what happens. All right, can you see this pressure gauge? Probably not. There we go. I'm just going to use the back of the alternator here for my power feed. I'm starting to not be able to feel my fingers. It's so cold. All right, got power on the end of my jumper wire, and go right to this connector. And I'm seeing some arcing, but we are not building fuel pressure. So what that means, let me get a good connection here and then I'll talk. I'll use my pocket screwdriver. What that means, being that this does not jump this circuit, is that means that we have potentially a bad fuel pump. And I say potentially because I have to do voltage measurements before I can call it, or I at least need to go down and beat on the tank, see if I can make it fire. And the thing about jumping this circuit the way we have it right now is I don't need the key on or anything. That should be jumping direct 12 volts into this pump right now. And I say should be, because we could have wiring issues. This is going into the normally closed contact of the relay. We could have a relay issue still that would affect this test. I'm just thinking about the variables here, guys. I did see it arcing initially, but now I'm not. Let's get our test light out and make sure we got power where it needs to be. Okay, should have power here. As you can see, I do. And then what I should have is I should have power on my gray wire to my pump. I'm gonna back probe this relay. I'll get you a shot of it in a second. Actually, I think you guys might be seeing that. Yep. So I'm just back probing the relay. That's the gray wire. That's the power to the pump. So that just confirms to me that my jumper wire is okay. I have a little PTC resistor in my jumper wire, acts as a fuse. And that answers that question, make sure that's okay. If you watch my test light down here, when I take this off, you see power goes away. So I'm forcing power to my fuel pump right now. I'm not seeing arcing, so that suggests there's no current flow and no reason to put an amp probe on this. We could do that and measure amperage. But I think the next step really is I'm gonna go beat on the fuel tank and see if we get pressure. I cannot hear that pump kick on at all. Powers and ground checks need to be done underneath to be sure, but basically this is looking like a fuel pump. I'm going to try doing an amperage measurement. I do not think it will be fruitful. Just going to go over my jumper wire here. Get you a shot back on the Pico. This was our injector pattern from before. We'll run this. Oh, cool, we do have an amperage reading here. I say cool because that is going to save me from crawling underneath this vehicle. Let me get some better measurements here. Let's do a 10 amp. And let me take my jumper or my amp probe off real quick. Make sure that we're not getting false readings. Re-zero it. Looks like maybe we were. Maybe have an issue sitting on this alternator. Yeah, there's a magnetic field right there in this alternator that's interfering with my amp probe, so I can't go there. Let's get away from that. And let's clip it on down here. Just getting away from the magnetic field of the alternator. And we do have some current, looks like 1 amp. Let me re-zero that one more time. Make sure that we're accurate here. Okay, we do have some current, so I'm not crazy in seeing the arcing that I saw. Let's drop our time base down and drop our scales down a little bit here. That's a pretty crappy looking waveform for sure. It's about 1 amp of current, which is definitely too low. Now, is there a test that I can show you that would prove the wiring is good, the power and ground underneath? We could have a high resistance power feed underneath. We're not worried about the relay or anything else. We could also have a high resistance ground. And I'm gonna try a test here. That's with my jumper off. Try to get that initial initial spike. What I was hoping for in this capture here, when you first turn a fuel pump on, you should be able to get a pretty high arc of current just because the pump isn't spinning yet. And that can actually give you good direction as far as wiring goes. So that's what I'm looking for. Look, here's what I'm trying to avoid, guys. I don't want to crawl underneath this car right now. It's snow all over the ground. I'm outside. I don't want to crawl under the car. Let that sit for a second. The initial spike is what I'm going after, so I'm going to set a trigger and we'll set it at 1 amp. I should be able to hit that. Let's do that on a single shot. See if I can catch this initial amperage. You see, I saw it right there. It's almost 2.5 amps, so we can take a measurement of that. Right there. 2 amps of current. 2 amps of current is enough for me, I think, to not crawl underneath this vehicle and make a call on this pump. I'd like to see that be a little higher than that. 3 or 4 amps of current would make me feel a whole lot better. On a good pump, you might see 10 amps on that initial turn on. Let's hit it again. Let's try it. All right, here it goes. Initial turn on of the fuel pump. That's about the same. Oh, something else I wasn't considering. One of you guys are probably screaming at the camera right now is, what about your test light? You're right. You gotta get that test light out of there because we're measuring the current flow of the test light too. So let's do that again with the test light out of the picture. Yeah, we see some spikes in there. Let's run this with no trigger for a minute. See, we're still running about 1 amp of current flow on that pump. It's just dead. Getting to the wiring on this is not going to happen. Or is it? Maybe. Maybe. I want to see higher amperage. Just trying to prove the wiring here, guys, that's all. You see the spikes I'm getting. I'm turning the circuit on and off. There's some higher ones there. That's a 3.4 amp spike. Guys, this is getting a fuel pump. I'm not crawling underneath this car in the snow to check the power and ground. I don't feel the need to. I'm going to make a call off of that. You see the conditions that I'm working in dictate that. This car is definitely getting a fuel pump. I guess the last thing that I can show you guys would be the data link connector, jumping the data link connector and counting the flashes of the light. That's not going to help us with the pump. We will have mass airflow sensor fault codes in memory because you see the mass airflow is unplugged. Also, a fuel pump that fails or is failing, we can now plug in, I think this mass airflow issue is with the mass airflow unplugged, the car is going to run better because it runs in a richer strategy. And so you can have low fuel pressure, the car's having a hard time running, you unplug the mass airflow and the car runs better. That would explain why the mass airflow is unplugged. And that's a warning too on the unplug it test, and that the unplug it test can be an issue sometimes. That you can't always rely on that unplug it test to tell you have a faulty mass airflow. All right, let's go inside the car and I will show you the data link connector. All right, so the first thing we want to do for these pre-OBD2 GMs, oh, and by the way, I think it was the 94 model year, did not have a pin in pin B. So A is all the way to the right, and then B is just to the left of that. And I'm just going to use my jumper wire here. I'm just holding the clips between pins A and B, that's all. All right. Then what we do is we count the flashes. That's 1, 1, 2. 1, 1, 2, and they'll repeat themselves 3 times. We missed the first one. 1, 2, 1, 2, 22. 1, 2, 1, 2. Code 22. 1, 2, 1, 2. 1, 2, 3. 1, 2, 3, 4. 34. I think that's the mass airflow. 1, 2, 3. 1, 2, 3, 4. They'll repeat each code 3 times. And then what it will do is it will go back to a code 12. The code 12 is a normal code. So if this goes back to code 12, we're done. 1, 1, 2, back to code 12. So we have code 12, which is normal, code 22, which I'm not sure what it is, and code 34. You can hear the cooling fan running, possibly. The other thing when you do this test on these older GMs is it actually energizes the solenoids and certain relays, so it allows you to do bidirectional testing, which is kind of cool. All right, so that's it. This car is getting a fuel pump. I guess I can look up that code 22 and report that to you, see what that is. Most likely that was somebody messing around under the hood.